Hey guys, welcome back to my channel. This is Varun Tahin. So now that we are done with the basic understanding of how Python programming works and have also seen some real-time examples of how to derive useful information given a data set by help of visualizations. And also we have seen the various ways to get the data from various sources in the data extraction module, in which one of the methods was to get the data from databases such as SQL. But that time we did not talk much about it as I wanted to take a dedicated session for that. So this session is to talk about SQL basically and to get a basic understanding of what SQL is. So in this session we will be seeing how to install various components to start working with it and check out some varied type of querying mechanisms. So let's begin. So the first question comes, why do we need databases? So databases is essentially required when you have large volume of data and we wish to be stored it at one place. Also sometimes multiple users want to read and modify the same data at the same time. Okay, so for that reason also databases are quite necessary to maintain user access and to manage the data. The third reason will be that databases are searchable and sortable. So the data you need can be found quickly and easily as per your need. So we can easily modify the data and we can retrieve it. And the fourth reason is that data structure is extensible in the database, so it can be modified as per the requirement. So guys, as you all know, SQL is a database and it will not be injustice to say that it is still the most widely used relational database, and it is literally aging back to 5 decades now when it was originated. Now SQL's full form is structured query language. So SQL is a structured query language which is a computer language for storing, manipulating and retrieving data stored in relational databases. Also SQL is the standard language for relational database system. All relational database management system like MySQL, MS Access, Oracle, Sybase, Informix, Postgres and SQL Server use SQL as the standard database language. So there are commonly 4 types of SQL commands which we can fire. The first one is DDL, which is commonly known as data definition language. The second one is data manipulation language. The third one is data control language, and then data query language. So we will be seeing each one of them in detail now. So when we talk about data definition language, it will be having several operations such as create, alter and drop. So as you can see on the screen, that create command creates a new table, a view of a table or other objects in the database. So it is self-explanatory. Likewise, alter modifies an existing database object such as a table, and drop deletes an entire table, a view of a table or other objects in the database. So by data definition, you have already seen that it is a definition of the database. So it is either creating the database, altering a table or dropping the table or a database. Now second comes the DML, which is data manipulation language, which have operations such as insert, update and delete. So as the name suggests, insert is to create a record, update modifies the record and delete deletes the record. Now third comes the DCL, which is data control language. So when we create a database, we would need some users to use it. So for that purpose, we would need some users to be defined inside the database and to be granted some permissions and to revoke some permissions after a while. Okay, so for that purpose, this data control language is there, in which grant command will give the privileges to the user and revoke will take back the privileges which we have already given to a particular user. And then at last comes the data query language, which is all you know is select commands, which retrieves a certain records from one or more tables. Now let us check some of the terminologies which we have already discussed. So the table you are seeing on the screen is the RDBMS SQL table with all the columns such as ID, name, age, address and salary, and the records being for each of the records of this particular person, such as Ramesh, who has age of 32, address in Ahmedabad and a salary of 2000. So this is a record, and a cell is basically a column and a row intersection. If I say get me the first row's first column, then it will be Ramesh, and therefore this becomes a cell. Also I would like to point out that nulls are accepted in SQL, and by default if we don't insert anything, the columns will be filled by nulls. But there are various constraints that we can apply on the columns, so we will be seeing that shortly. So as we have discussed, we can have various SQL constraints that can be applied on columns, and that are non-null constraints, unique constraints, primary key, foreign key, and check constraints. So we will be seeing each of them very formally in coming sections. Now RDBMS has data integrity constraints also, which defines that a row will be defined with these rules, and these rules cannot be violated in this system. The first one is entity integrity, where it says that there are no duplicate rows in a table. Then there is domain integrity, which enforces a valid entries for a given column by restricting the type. Then there is referential integrity, which says rows cannot be deleted which are used by other records. And the last one is user defined integrity, which enforces some specific business rules. So we will be seeing each one of them. Now these are some of the data types which SQL uses for each of the use cases. Let's say that you want to use some characters, then you can use char and varchar2 and varchar2. Then if you want to use some numeric, then you can use these data types such as number, binary float, and binary double. And if you are defining a date, or if you want to sort something, then you might use date as the data type. So you can get various description for each of these data types for its usability and when it should be used. Majority of the data types are pertaining to the length of the characters. Basically, if you are talking about the character data types, and if you want to use some decimal places, then you should use the double or float. So in those ways it is quite different. So I will be giving the link in the description also for you guys to go through each of the data types. So guys, now we will be creating a scenario to discuss what we have defined as each of the terminologies and how they work in specific places. So for that, we will be creating tables and using SQL commands to understand the concept and the flow of operations in real time when we work with SQL. So guys, please pay attention. We will be firstly seeing them concept wise and how they function, and then starting from the next session onwards, we will do hands-on by installing the SQL workbench and creating the tables by our own hands. Basically, when we start with any of the database, we would need to define some users for our database. So defining a user means to give them a username and password and grant them sufficient privileges. So it can be done very easily in SQL. So you can see this window on the screen. This is a terminal window for SQL workbook, and it has command to create the user first and then grant all the privileges to that created user. So it says create user, test user, identified by 1 2 3 4 5. Okay, so this is kind of an ID it is giving it to that user, and then it is granting all the privileges to that user. So we can also give specific privileges to a user, but that will not be a scope of this session. So guys, now that we have defined the user for this database, we will create tables that we require. So here we are creating a person table which has various fields like name, last name, father name, birth date, gender, and international social security number. So guys, here ISSN is created as a primary key. So primary key is the key field which is unique in the table for all the records. So this is for identifying the record uniquely and to query it more specifically. And also a note here guys, that it can be a single or composite, that is containing more than one column to define it unique. Now there is a phone table you can see on the right side that has phone number as the primary key along with the other columns, and also has owner ISSN, which is a foreign key that we have talked earlier. Okay, so that will point to a person table ISSN so that a link is established between the records in these two tables. So for an example, for a person that has the same ISSN in both the tables will be linked via this referential integrity that we talked about in data integrity. Okay, that is happening because of this foreign key. So guys, here you can observe how do we create a table also. So we use create table command with the name of the table that we want to create along with the particular columns that you need to use alongside their data types. So ISSN is a number. So first name is a varchar2 with a length of 100 and which has a constraint of non-null, so it cannot have any nulls in it. Likewise, last name also cannot have nulls in it. So we can define it like this, and at last we need to give what is the primary key. So we have chosen ISSN as the primary key. Likewise, for the phone table, we have chosen phone number as the primary key with the number as data type and activation date as one of the columns, and we define the foreign key as owner ISSN with the data type and with the keyword references and with the name of the table where we are referencing it with the column name of it. So owner ISSN is linked to ISSN of persons table. Now we have also seen that DDL contains drop table, alter table and other commands also. So apart from create, we can drop the table. First screenshot we can see that we are dropping phone table. So we can use drop table phone, and for altering the table, let's say that we want to add status as one of the columns in the phone table. So we need to give alter table phone, add status and give the data type of it. So here we are using character, and then we can even drop the columns which are already existing from that particular table. So let's say that we have already added status. So if we want to drop it or delete it from that particular phone table, then we will use alter table phone drop column status. Now guys, that we have created the tables, now we'll see how to insert records into the table. So the first screenshot you are seeing on the screen will insert the record. So three different records, because the primary key is changing there. So ISSN is changing as 1, 2 and 3. So it will create different records. So the format or the syntax to create or insert the record into the table is insert into and then table name with values, and in brackets we have to give the values for the columns we have created, and this should be in sequence. Okay, the order should be maintained, guys. So the first one was ISSN, then the first name, last name, father's name, date of birth, and then the gender was there. So you can tally. So it was like this: ISSN, first name, last name, father's name, birth date and gender. So the same way we will insert the values into the table, and just keep in mind the data types that you have given while you have created those columns. So these were varchars, and this was date, and this was a character, single character. So these integrity should be maintained. Now guys, in the second screenshot you are seeing on the screen, which is at the bottom, you can see this error will come when you try to insert another record with the same ISSN, that is same primary key. As primary key is the unique constraint, so it has a rule that it should be unique in a table for all the records. When you try and insert a record with the duplicate ISSN, it will give you an error of unique constraint violated. So you will not be able to insert this into the table again, because one is already present as the ISSN in the first record. Now there can be cases where you want to put the values inside the specific columns only and not all the columns. Okay, like in the first screenshot we are filling the birth date, father name, last name, first name and ISSN. So for that we have the structure where we give insert into the table name, along with it in brackets we will give all the columns in which we want to insert the values, and then we will give values, and then in brackets again we will give the values for those particular columns. Now there is one case that arises when you try and insert some values but you are ignoring the non-null columns there, and you are not putting some values inside those columns. Okay, so in those cases this error will come. Okay, so it says that SQL error, an attempt was made to insert null into the previously listed object. So it is actually assuming that for the ones which we are not giving the values, those columns are regarded as null. And you can see that we have not considered last name in this second screenshot, but this was a non-null entity. Okay, so you need to give any value to it. So it is mandatory that you need to give the values to first name and last name, because those are non-null columns. Now as we have created the records in the first table, that is primary table, we need to create records in the phone table also. Okay, syntax remains the same. So we need to use insert into phone values and need to give the values there. But here we need to be careful about what we insert as a foreign key, because it will only accept the values which are already present in the first table as ISSN. Okay, so whatever you have given as the ISSN value in the first table, that is the person table, we need to use the same values for the foreign key also in this phone table. Okay, so you can see in the second statement, that is this insert command, this is giving us error that a foreign key value has no matching primary key value. Okay, integrity constraint violated, parent key not found, because it is trying to reference this to the first table. But in the first table we had only 1, 2 and 3 records inserted as ISSN, but here we are giving 11. So that is the reason. Now when we insert some records in the table or update some records in the table, we need to make sure that we put commit as an additional statement after all this. So until commit happens, the records will not be inserted or persisted permanently into the database. So you can see in the first screenshot that the person table is updated with father name and then it is rollback. So rollback means that it is not persisted permanently into the table, but in the second screenshot we can see that we are using where clause and we are committing the updated record. That is, we are setting the father name as Reza where ISSN is 1 and we are committing that record. Now we have seen drop command previously, which was a DDL command. There's an identical command called truncate. While drop drops or deletes the table completely, the truncate command will basically empty the table and its records. And so there is delete in DML also. So what is the difference between a delete and a drop? If we delete it, we have an option to roll back also. But when we drop it, we don't have an option to roll back. Okay, so you can see here that when we are deleting person, it is not allowing us to delete it completely because it says that an attempt to delete a parent key value that had a foreign dependency. So this error is occurring because the foreign key is used in the table 2, that is the phone table, and it has this dependency over this table, and that is the reason it is not allowing the parent table, which is the person table, to get deleted. Now delete command is specifically used to delete a specific record. So when we use this command in the second screenshot, let's say that we use delete person where ISSN equals to 2 and do a rollback, it is not giving us any kind of errors here. Now guys, the thing you are seeing on screen is the entity relationship diagram for the HR records. So we have several tables like HR job history, HR departments, employees, jobs, location, countries and regions, and we have established the relationship by using primary keys and foreign keys and have developed this chart. Now using this chart we will be querying and we will be showing you guys how to query. So we will be focusing our mind on majorly the employees and the jobs table. So now let's focus on the employee table. So to get all the records we can use select star statement. Okay, so select star from employees. Okay, so we have to give the table name as well, which is employees, and we will get all the records of that table, so which is the first screenshot in this screen. Now we can even get the specified columns. So if we want to choose only the first name and last name, we can do select first name comma last name from employees and we can get those particular two columns. Now there's a distinct clause that we can use alongside the column name. So you can see the difference when we do select department ID from employees and select distinct department ID from employees. So the difference here is that we will get unique record in the second case, but in the first case we are getting the repetitive records, or they can be the redundant records can be present there in the first case. So always the number of distinct records will be either less than or equal to the records which is present in the first case. Now where clause can be used when we want to apply a certain conditions. So the syntax is that select, then we should give the column separated by commas from table name where condition. Like you can see in the first screenshot, it has mentioned that select star from employees where department ID is equals to 100. So it will filter the department ID's value 100 and it will return all records which have the department ID as 100, that you can see in the right side of this first screenshot. So we can also filter it by an and or condition. So there can be multiple conditions that we choose to operate on. So we can specify all those and specify and or condition and it will still work. So in the second case, we are selecting the employees which has department ID as 100 and first name which starts with J. Okay, so like is used for partial search operations. So it will search in the first name and whichever first name is starting with J, capital J, it will return all those records. So in this case, both the department ID condition and the first name condition is met because we are using and here. And you can see that department ID is 100 and the first name is returned as John and Joe's Manual. Now we can also give in clause and not in clause in the where clause itself. Okay, so you can see on the screen that we are using in clause. So we are selecting all the columns from the employees, that is we are doing select star from employees where department ID in 100 and 90. Okay, so where the department ID is matching either with 100 or 90, it will return all the records. Okay, so this can be supplied as a list, and likewise we can use it for not in condition also. So let's say that we had not in here, it will return other records which is not matching 90 and 100 in department ID. Now likewise with where clause we can use is null and is not null clause also. So the second screenshot you are seeing on the screen at the bottom, you can check that first two cases are the wrong ones where we are using null and not equals to null wrongly. Okay, so the correct way of doing it is the rest of the two ways, that is the last two commands, that is select star from employee where department ID is null and select star from employee where department ID is not null. Now we can also order the records returned by SQL, okay, by using the order by clause. So you can check on the screen, the screenshot says select star from employees where department ID equals to 50, order by salary. So it will return all the records where it is having the department ID is 50 and it will reorder the records as per the salary. So the default ordering here is ascending. Okay, so if you don't give anything, it will conclude that it is in ascending order, and hence you can conclude that salary is appearing in ascending order here. That is 2100 is coming, and then 2200, and then 2400, and then 2500. Okay, so it has sorted the records by salary. Now if you want to give in descending order, this is also possible, and you have to just give DESC just after the column name, that is order by salary and then space DESC and then semicolon. Now if we want to perform some aggregation functions, we can even do a group by clause on some columns. Like we can see on the screen, it is actually returning the department ID, the total count of or the number of employees, the average salary from the employees table, and it is basically grouping it by the department ID. So it will basically do a grouping on the department ID, check which all records have the same department ID, and then it will select their department ID, count them and calculate their average salary. So in this number of employees and average salary are the new columns which are returned, and they will give the aggregate of those particular groups. So we can even use different aggregation functions like max, min, average, count, sum, and there are some other aggregation functions. So this query will best suit when we want to count the number of employees in a department and calculate their average salary. Now we can even fire select statement from multiple tables. Like we can see on the screen, this query will be querying the two tables, that is the employee table and the jobs table. So these are alternative queries which will do the same thing and will return you the same output. So this is doing a select count star, that is it is counting the number of employees where the job ID in the employees table and the job ID in the jobs table is equal. So it will fetch the job IDs of the employees table, tally it with the job ID of the jobs table, and then it will return all the employees counts. So the second query is using the join operation with an on condition. So guys, I will be putting all the resources of SQL content which I will prepare in the GitHub repository, and I will give this link in the description also for you guys to go through, and you can check that I have already uploaded some of the contents. In the next sessions we will be going through the installation phases, for which I have already put the installation guide for Windows and Mac OS and some data sets that we will be using in the next sessions alongside the PPT that I have used in this session, so you can refer this too. So this was the end of today's session on introduction to SQL. In the next session we will install SQL in our system and get our hands dirty with some of the queries we learned today using a real life example. Until guys, I would like you to go through the contents once more so that you are thorough with what we will do in the next session. Also, please do subscribe my channel and hit the bell icon if you don't want to miss any updates. Please like and share the content with your friends and spread this channel as much as you can, because as you know that this is one stop where you will get everything related to data science for free. Please stay safe with your loved ones. I will meet you soon in the next session. Until then, thanks and take care.